example, consider the spring mass damper system shown where the input is U, the output is Y. Okay, the system is drawn here. Here is the input U. This is an old system which you all know, but it's always used. It's nice, it's simple. We can use it at the beginning, then we'll take more complicated example. And we have a damper. And a spring. And they attach to a fixed hinge to it. K, that's B, that's Y, okay? And assume that the system starts from equilibrium so that we don't have initial conditions. And I remind you of this equation of this system, okay? The equation is, we can say, equation of motion my double dot زائدا by dot زائدا ky equal u of t. Of course, as you know, this is a second order differential equation, so we're going to expect that the A matrix, will be 2 by 2, okay? This matrix, because it's a second order system, will have two states. That's mean x1 and x2, okay? Let's assume that x1 is y, x2 equal y dot, okay? From here, we'll have x1 equal x2 dot. I'll put it here again, x1 dot, equal x2, not that, okay? Equal x2. This is an equation, it's a state equation. We have differential here and we have state here, okay? This is one equation. I'll call it 1. And then we have, from here, we have x2 dot equal y double dot, okay? Y double dot from the above equation equal, y double dot equal to minus k over my minus b over my dot plus 1 over m u of t, right? Or x2 dot equal to minus k over m, what's y? It's x1, minus b over m, what's y dot? It's x2, plus 1 over m u of t. Now notice, this is a very important note. Here we'll have the derivative, so x2 dot will have x2, x1, x2 dot will have x1, the state, x2 dot will have states, you see, x1 and x2, which we assumed here, and it will have the input, and would have the parameters of the system, nothing else. So if you have x1 dot here, you will have either x1 and x2 and the input. Same thing here, we have x2 dot, we have x1, x2 and the input. So now we have two equations. Sorry, I got to the bottom the side of the paper. We have two equations, 1 and 2. Now we can put them into the matrix form. So to form A, B, C, and D. Okay? The output, let's continue with the output, is y of t. And it's equal x1. Then y of t equal 1, 0, x1, x2. I can write it first here, and this is in a matrix form now. Now from here, from equation 1 and 2, we can say x1 dot x2 dot equal what do we have? We have 0, 1. What do you have from second equation? Minus k over m. And the next one, minus b over m. And what do we have? We have the input. 0, 1 over m. And what's this? U of t. Okay? So I have now completed the, although I should put this first and this one at the bottom of the system equation first, but it doesn't matter really. They are like simultaneous equation. You can put whatever you like. Now, what is this? This is A matrix. 2 by 2. What is this? State vector. Okay, 2 by 1. Okay, what is this? B matrix. This is a single input, single output. So it is 2, which is the order of the system, by 1. Okay, and what's this? This is the input. The input here is a scalar because it's only single input. And what's this? They say it's derivative. So if you notice this equation of state variable, it's a state differential equation. Each equation, if you notice from the beginning, each equation, even here, it's a first order differential equation. So like, Anna, what did I do effectively? I changed a higher order differential equation into a set of first order differential equation that makes it easy to solve on computers. That's the main tasks, to make it more systematic. I can find systematic solutions so I can solve it on the computer. What is this? It's C matrix. واضح? So that's a simple example. We can find the equation is simple. We wrote the equation in a systematic way. What's left is we have to put the block diagram, okay, for the system. What did we say about the system? It's a second order system, right? Second order system, we said at the beginning that if we have second order system, you need two integrator to get the variable. So I'll make one integrator like dt. I have x2 dot here. So I integrate, what do I get? I get x2 after integration, right? And then another integrator. If I integrate this, what do I get? I get x1. And x1 equal y of t, right? Now, we said that the feedback which we get, it's related to A. So if I make a feedback from here, B over M. And I'll make here and I'll make another summary here. And what do I have? The input is on 1 over M. This is U of T. Okay. Now I have from x1, what do I have? If you remember the equation, I have K over M. Now I sum this to here. This is a summer, of course. and now I go there. Remember, those have negative equation, negative sign in the equation. So if I go here, and this one I sum them here and go here. Here I put negative sign, okay? Because this one and this one, they both have negative sign in the original equation. Now I have x dot. If I integrate, I get x2. If I integrate, I get x1 because I have the equation x1 dot equal x2. Now if I integrate, I get x1, which is the output of the input. This is the output of the input. And now I fed it back here and here like that. So this is the block diagram of the system. Notice that I don't have a D matrix in this system because I don't have a connection between this input to the directly to the output. This is a block diagram. Here I can put the block diagram of spring mass damper. Here it is. Okay. I'll stop here. مثل ما حكيت لكم إذا الفيديو يصير أطول يمكن صعب يعني أعمل أبلودينج لأنه عارفين مشكلة النت الآن. فأختم الآن. I hope this is the easy part خلينا نقول واللي أنتم ماخذين يمكن كثير أشياء منه وإن شاء الله أعمل لكم فيديو ثاني. What I need from you بعد ما أبعث لكم الفيديو طبعاً إنه تعملون سبسكرايب وبعدين أنتوا احكوا لي ابعثوا لي إيميل أو راح أبعث لكم رسالة كمان تبعثوا لي مثلا أرقامكم يمكن نعمل واتساب جروب easier حتى نشوف إيش الانتقادات وإذا تحبوا تغيروا على structure of the video أو إشي مش واضح كمان tell me please. Okay, thank you, bye bye.